So in this lecture we are going to do a few more problems on MOSFET in the gate. So this question came in gate 2014 for 2 marks. For the NMOS, VTH or threshold voltage is given as 0.8 volt. Neglect the channel and the modulation. When VD is equal to 1.6 volt, ID is equal to 0.5 milliampere. So he has given one condition, and if VD is equal to 2 volts, the new value of ID in milliampere. So how to do this type of problem is, so using the current expression, which is Kn dash by 2 W by L VGS minus VT whole square. What is this reason why I have taken this expression is, if you see the circuit, drain and gate are short circuited. That means I can say VDS is equal to VGS because source is grounded or source is common. Now we know that VDS is greater than or equal to VGS minus VT for saturation region. Now we know that both equal, so I can say VDS is always greater than or equal to VGS minus VT, because VGS I can say this is VDS minus VT. So VDS minus VT always is less than the VDS, so I can say the transistor is always in saturation region. So that's why I will use this expression. He has given ID is equal to 0.5 milliampere, so 0.5 milliampere. Now he didn't mention about this Kn dash and W by L etc. So I will use simple as K, and VGS is equal to, we have seen already VDS, so VD is given 1.6, so I can use 1.6 minus VTH is given 0.8 whole square. So I can say K is equal to 0.5 milli by 1.6 minus 0.8, so I will get 0.8 whole square. So this K we got in the first expression. Now we will use this K for the next. So next problem is given VD is equal to 2 volts, so the new value. Again I will use ID is equal to K into VGS minus VT whole square. So in the second equation, VD is given 2 volts. That means VD is equal to VS. So ID is equal to K we have already found, that is 0.5 milli by 0.8 square into VGS is equal to VDS because this from the circuit. So I can say 2 minus 0.8 whole square. So it is like this. So 0.5 milli by 0.8 square into 2 minus 0.8. So it is 1.2 square. If I solve this, what I will get, ID is equal to 0.5 milli by, so 0.5 divided by 0.8 square into 1.2 square. So it is 1.125 milliampere. So this is 1.125 milliampere. So this is how to find the ID. Right? So very simple. So we need to use this saturation region of this. Next again one more problem we will do, that is came in again gate 2014 in different set, that is for 2 marks again. He is mentioned for the MOSFET M1 shown in figure, assume W by L is given 2, VDD is 2 and mu1 Cx is given 100 microamps per volt square, VTH is equal to 0.5 volt. Is mentioned one condition, that is the transistor M1 switches from saturation region to linear region when Vin is equal to dash. So this, for this we may require 2-3 equations. The first one is VDS is greater than or equal to VGS minus VT for saturation region. That means the minimum voltage VDS should be VGS minus VT. If VDS is less than this, so the transistor will switch to linear region. So if I find this expression and using these values, we can find the V in for the saturation to linear region. So we know that ID is equal to Kn dash by 2 W by L into VGS minus VT whole square. Now he is mentioned W by L is given, VDD is given, mu1 Cx is given, VDH is given. So I can say ID is equal to Kn dash is given 100 micro, that is mu1 into Cx by 2, W by L is also given 2. So we don't know VGS minus VT. So VGS is, I can say from this expression, V in is VGS, that is VG minus VGS. So Vin minus Vt is given 0.5 whole square. So this is ID. Now from this expression and from the circuit I can say Vout is equal to VDD minus ID into the 10 kilo ohm. Now what is Vout? So Vout is equal to Vd, right? So this is Vd and VDD is given as 2 volts. So 2 minus 10 kilo into ID. ID I can substitute this, so 2 cancel. It will become 100 micro into Vin minus 0.5 square. So 100 into 10, so it will become 1000. So 1000 kilo into 100, I mean 1 micro, both everything will be cancelled, it will become 1. So Vd from this expression, Vd is equal to Vgs minus Vt. What is Vgs again? Vin. So I can take Vin minus 0.5 is equal to 2 minus Vin minus 0.5 square. And if I expand this, 2 minus Vin square plus 0.25 minus Vin, because A minus B whole square formula. So this is Vin minus 0.5. If I take this expression here, so Vin square plus 0.25 plus, so it will become minus Vin plus Vin minus 0.5 equal to 2. So plus Vin minus Vin will be cancelled, minus 0.5 plus 0.25, so we will get minus 0.25. So Vin square is equal to 2.25. So Vin is nothing but 1.5 volts. So this is how to find the Vin as 1.5 volts. So again this is condition for saturation region. So if Vin is less than 1.5 volt, then we can say the transistor will enter into the saturation, linear region. So this is how to find the some problems on the MOSFET, right?